computing these things by hand, it's a lot easier to divide by a whole number than it is to divide by an irrational number. Okay, so are these things the same? Well, you should get yes, we should rationalize this. Is that why you were asking me this? Because you wanted me to rationalize this, right? So this is plus or minus 4 square root 3 over 3. Is that the same as this?
Yes.
No.
No. No.
So why not? It's supposed to be, isn't it? It's an identity. It should be the same.
No, it'd be 2.
What if I were to multiply this by 3/3?
Yes.
Oh, then yes, it is.
Yeah.
I was like,
Multiplying by 1 changes everything. No, it doesn't change anything, but at least then you can see it's more obvious, right? So you got 3 root 3s plus 1 root 3, it's 4 root 3s all over 3, right? So yeah, these are the same. That's good. How about pi over 4? What's a tan of pi over 4 is 1, right?
1.
Tan of negative pi over 4 is negative 1. So I can write plus or minus 1 for plus or minus pi over 4. Same thing with cotan, right? So that's going to be equal to plus or minus 2? Because it's the same sign on each one, right? So in the first quadrant, they're both positive 1. And in the second quadrant, they're both negative 1. Secant of pi over 4? It's square root of 2, right? Cosecant?
Huh?
Well, plus or minus square root of 2, right? And we're multiplying here. So what do I get when I multiply positive root 2 times plus or minus root 2? I get plus or minus root 2, right? All right, sorry, it's just plus or minus 2. So that's looking good. Let's turn this thing on because we can maybe make use of some things. All right. How about pi over 3? Well, that's going to be the reciprocal of pi over 6, right? Because they're reversed. So tangent is going to be plus or minus square root of 3, and cotangent will also be, it will be plus or minus square root of 3 over 3. And then here it's going to be plus or minus infinity plus 0, yeah, whatever. The idea is that it's undefined. Tangent is undefined at pi over 2, so this is also going to be pi over 3 up there. The cosine is going to be 2. Plus, actually,
2.
secant will be positive 2, both above and below. So for both angles, the x-coordinate is the same.
Also 1.
Sorry, square root, right?
That's fine, thanks.
And then this is going to be plus or minus.
2.
What am I doing? I'm in the wrong place.
Yeah.
Yeah, so I was right about 2.
Yeah.
And then this is times plus or minus 2 over square root of 3, right? Which is plus or minus 4 over square root of 3. And that's the same as the other side, right? And this is again, I didn't finish this one. I said secant of 0 is 1, but I forgot to finish, what's the cosecant of 0?
Cosecant.
It's undefined.
Yeah, this is, you can write infinity, plus or minus infinity, I guess, whatever. It's undefined, right? So, and same thing here, right? You're going to get plus or minus infinity times 1, which is plus or minus infinity. Okay. So, but you could also use a graphing utility. They don't say to use a graphing utility, but if you're actually going to graph those points, you're going to get the same points for both. And so what I suggest, if you're using a graphing utility, is that you graph the left side, which is well, here I have to use x, okay? 'Cause so there's the tangent function. Does that look familiar as the tangent function? No, it's that kind of a sigmoid. It's kind of like a cubic, except it has vertical asymptotes, right? And it's periodic. So what happens if I add to that cotangent? So plus cotangent x.
Keep a cosine.
I put cosine. Yeah. Look at that.
Wow.
Does that look like what it ought to be? Hard to say. We're getting, is that consistent with these points here? So if I say, give me the point which has
Yeah, 2.
pi over 6 as the input, and this function is called f, so I'm going to say f of pi over 6 as the output. There it is, right? Is that, what is this?
4 square root.
Well, root 3 is approximately
2.
1.732, right? So if I divide that by 3, I get 0.577, something like that. And so if I what do I get if I multiply that by 4? So 4 times root 3 over 3 is approximately, I meant to say approximately here. This is also an approximation, isn't it?
Yeah.
So 4 times that is going to be 2 point, 14, so you have a 1 in this, or 28, you have 2 here, but then this is going to carry, so you're going to get 2.33 maybe? Is that right? What do we have on, oh, we have 2.31. Okay. And for pi over 6, we have 0.52, is that true? Is that pi over 6? Pi is about 3, right? So a little more, right? So pi over 6 is a little bit more than a half.
Yeah.
So 0.52 seems like a little more than a half. That's in the ballpark, right? And, this other value, I guess this is supposed to be, it's like, yeah, there's a 1 here, right? So, 8 plus 3 is 1, or something nearer to 1 than to 0. Yeah, so it's approximately 2.3. So that's correct, right? And that gives me this point here. What about these other points, pi over 4 and so forth? So if I got pi over 4 and f of pi over 4, that's that point. Looks like an actual minimum right there, huh?
Yeah.
So that's 2. So the input is 0.79, that's pi over 4 approximately, and the output is exactly 2.
Yeah.
And this next point is the same, you can see it's symmetric on the other side, right? So we're going to get another point like that one. So these 3 points, together with the idea that we have these asymptotes at 0 and pi over 2, are those visible here? What if I draw the line
Almost.
x equals pi over 2? Pi over 2. Now that's a vertical asymptote, right? I make it dotted because object properties, style, dotted. There we go. We like our asymptotes to be dotted. That's nice. Or dashed, I guess. Dash is nice. All right. And so 0 is a vertical asymptote, pi over 2 is a vertical asymptote, and these are points in between. So it seems to be reasonably good. How about the secant times cosecant? So here's secant x. Secant x. Oh, I can rename? I don't want to rename. Cancel. And down here, we've got secant x. There's the secant function, right? Look familiar? It's got vertical asymptotes along pi over 2, 3 pi over 2. Multiply cosecant x. I get a curve a lot like the other curve, right?
Yep.
So here's what we can do to sort of drive that home. So what's the name of our function? H.
H of X.
H of x is what they're calling that. So I can call it, so I can graph h of x minus shift. Can I, supposed to have the word shift in there? Create a slider for shift? Yeah. Okay, so my shift is currently 1, I guess, and so if I make the shift 0, then they coincide, right? And then you can see that in fact it's the same shape shifted over. Oh, I can shift it over here, and it agrees again, right? No, almost. 3.14, what's that? Oh, it's 3.15 it says actually, doesn't it? And so that's pretty close to pi, so it almost coincides again when you shift by pi, because it's periodic with a period of pi. Okay, so that's number 39, with a little review of basic trig in the process, right? The usual suspects and whatnot